So here's an example of an application of a composition of functions. So we've got a boy who's flying a kite, and it says that the height of the kite is 3/4 of the length of the string connecting the kite to the spool that's held by the boy. So we want to express the height as a function of the length of the string. So it's going to be h of L. So we'll use h as the height of the kite, L as the length of the string. So those are our two variables. So it says here the height is 3/4 of the length. So I'm just going to say 3/4 times L. So whatever I plug in for L multiplied by 3/4, that will give me the height of the kite. So now in the second part, it says suppose the boy lets out 20 feet of string per minute. So now we want to express the length of the string as a function of time. So now L is going to be our output variable and T is going to be the input. So we've got a function of L in terms of T. So if the boy is letting out 20 feet of string per minute, we can say that it's going to be 20 times T. However many minutes have gone by, multiply that by 20, and so that's going to tell us the length of string that has been released. Now, if we know how much string has been released, if we know the length of the string, then we can work back to this function here and figure out what the height is. Well, what if we wanted to use composition so that we knew what the height of the kite was as a function of time? And so we're just going to plug one function into the other. So it might be easier for us, instead of seeing it in function form, to see it as h equals 3/4 L and L equals 20t. So if I want to get h in terms of t, I'm just going to do a little substitution. I'm going to replace L right here with this 20t. So we're going to have h equals 3/4 times 20t. So that gives us a function h in terms of t is 3/4 times 20, is 15t. So this is how we can use a composition of functions to make the leap from time to height instead of having to have that intermediate step of figuring out the length of the string. We have to find the domain of the composition of two functions. We have to not just look at the finished product, that final equation after we've built that composition, but instead we have to consider what functions factored into that composition. So g of x, for example, x squared, our domain for that function is all real numbers. On the other hand, for f of x, since we can't take the square root of a negative, our domain is going to be x is greater than or equal to 4. So if I do x minus 4 is greater than or equal to 0, and then add 4 to both sides, we have to plug in numbers 4 or larger. So we want to store that in the back of our minds as we try to find the domain of the composition. So for f of g of x, what that means is I'm going to be plugging g of x into f. So I'm going to have f of x squared. So that means I'm going to take x squared and replace it, plug it in for x in the f function. So I'm going to have the square root of x squared minus 4. So my f of g of x function, my composition, is the square root of x squared minus 4. Now when I look at this final product, I have to think about what values of x am I allowed to have in my domain. So I can't plug in 0, for example, because I'd be taking the square root of a negative. I can't plug in 1. So hopefully we can see that we need to have values of x have to be greater than or equal to 2, because as long as I have a value that's bigger than 2, I'm going to be in good shape. I also have to consider the negative side. So if I plug in -1, that's going to give me a negative value underneath the square root symbol. But if I bump up to -2 or go bigger negatives than that, then I'm going to be fine. So I've got x has to be less than or equal to -2 as well. So really the best way to write this would be a domain of x is less than or equal to -2, or x has to be greater than or equal to +2. And so I need to take a look back to make sure that those values are okay with the first function that we used in this sequence to get to this composition. And so that's where I have to look right here at x squared, the function that we plugged into f to eventually get our composition. And since the domain of x squared is all real numbers, then there's no additional restrictions that we need to put on our final answer here. So we had all real numbers as a baseline, but then after we took the composition, we had to restrict that a little bit to eliminate those numbers between -2 and 2, so we're in good shape with this domain here. In the second example, where the functions are reversed, so now we have g of f of x, so we're going to have g of the square root of x minus 4, and so that means we're going to take the square root of x minus 4 and plug that into our g function, so we're going to square that, so we end up with g of f of x equals, the square and the square root cancel each other out, so we get x minus 4. So in this case, if we look at the final result, we see that we can plug in negatives, positives, 0, anything we want. So our first thought is our domain is going to be all real numbers. But again, we have to go back to the functions that were used to build this. So the original function that we were using was the function f of x, which is the square root of x minus 4. And into that function, we already established we can't plug in anything that we want. We have restrictions, we have limitations. And so that means that we have to adopt those limitations for the domain of our composition. So instead of a domain of all real numbers, as it appears it would be by just looking at the finished product, if we look at the sequence of functions that were used, our original function that was used to build this composition had a domain of x is greater than or equal to 4, so that has to be the domain of my composition of the two functions. For our last one, g of x, so we're looking at g of x written this way, so I'm just plugging the function back inside of itself. So to start off with, we have g of x squared, and so then I plug that back in, so we get x squared squared, or g of x is x to the 4th. So in my final result, my initial thought is it's going to be all real numbers because I can plug in anything I want into x to the 4th, negatives, positives, 0. As a double check, I go to the original function that started this process, which was x squared. That also has a domain of all real numbers, so I'm in good shape here with an all real numbers domain for my composition.